Class. Yes, so hello everyone. Welcome to IT and Gate classes. This is lecture 1 on discrete mathematics. And in this lecture, I will give you basic introduction. Okay, so discrete mathematics broadly has 4 parts: logic, combinatorics, set theory and group theory, and graph theory. Okay, broadly 4 parts are there in discrete mathematics. And first of all, let me tell you something about logic. Okay, so logic, you can say it is the base of your computer science. Okay, if you know logic, then most of the subjects directly indirectly you know, and you will be able to solve most of the gate questions from logic itself, even though you may not be able to remember the concept behind the things and so on, but still you will be able to solve the question purely from the logic point of view. Don't worry, when I will dig deep into this topic, I will give you idea of how to solve questions and all those things. Okay, so according to me, logic is one of the very important topic. Okay, you should be able to grasp it properly. Okay, yes, so yeah. Next is combinatorics. Okay, so combinatorics, whenever you see the question like how many, okay, for example, in each and every subject you will find the question of how many. Like in TOC, you say how many FAs are possible, okay, and in your DBMS you say how many conflict serializable schedules are present and so on. How many conflict serializable schedules, okay. In networking, we use how many stations can be attached from a network and so on. So wherever you see how many type of question, all these questions are directly and indirectly linked to the combinatorics topic. Okay, so again, this is very important topic, and I always request to all the students that you should at least know logic and combinatorics. If you study these two topics meaningfully and very carefully, then most of the GATE syllabus is over. You can think like this: most of the GATE syllabus is over. Now your duty will be to study basic concepts of every subject. Basic concepts. Okay, if you know the basic concepts of the subject, you will be able to solve the GATE questions. Because most of the students say, sir, our concepts are clear, but we are not able to solve the GATE questions. Okay, so directly and indirectly you are not able to solve GATE questions because your logic and combinatorics is weak. Okay, you have studied conflict serializable schedules and so on, but question will be how many conflict serializable schedules are possible. So it's no longer related to your DBMS. It is no longer related to your DBMS. It's related to combinatorics only. Okay, so if you study these two topics properly and carefully, and then you just have to focus on the basic concepts related to each and every subject, and you will be able to solve the GATE questions. Okay, logic and combinatorics provide you the approach to solve GATE questions. Okay, these two topics will provide you approach to solve GATE questions. Okay, you will be able to solve GATE questions very easily if you know these two subjects properly. Okay, and most of the true false questions in GATE exam, they can be tackled with the help of logic only. Okay, if you know the basic concept and you know the logic, you will be able to solve most of the true false questions. Like you see now, which of the following statement is true, which of the following statement is false, and so on. Okay, we have studied your TOC. Okay, so we say every finite language is regular. So from implication, from logic, I will say every finite language is regular. So finite implies regular. Okay, so this is one-way theorem. So now 4 questions will be asked. Not regular implies not finite. This statement is true because it is contrapositive. Not finite implies not regular. No, this is false. Okay, because it is inverse. Converse will be regular implies finite. No. Okay, so by logic itself, you will be able to tackle all these 4 questions. Okay, no need to find any counter example and all. For example, regular implies finite. So if language is regular, then it should be finite. So you have to think a counter example like A star. A star is not finite and still it is regular. So this statement is false. Okay, and so you have to think counter examples in GATE exam. But if you know the logic, you need not remember this counter example and all. You will be able to answer questions directly. Okay, that is the beauty of logic. Okay, so with the help of logic, you can easily answer true false question and all those things. Okay, let me jump to the next slide. Next is set theory. Set theory, I call it as a one-line questions. Okay, the very simple questions and very easy questions have been asked on set theory. But the only thing is this set theory part is very lengthy. It is very vast, or it is huge. Okay, and we will try to spend as much time as possible on set theory. Okay, but this topic is really very huge. Okay, but the questions are really very easy. The advantages, questions are easy, but the disadvantages is really very huge. Okay, we have to study basic concepts of sets. Okay, then we will jump to relations. It will take a lot of time. Then functions we will study. Okay, and then we will, if time permit, we will study group theory also. Okay, and we will study your lattice theory also. So if time will permit, we will study these two topics also. Okay, but these three are must. These are very, very important. Okay. Yes, so it's really very huge topic. We will try to spend as much time as possible, but the questions, advantages questions are very easy. Okay. The last part is graph theory. Graph theory, I should say, this is really very vast topic, and the problem is that in GATE the syllabus is not precise. Okay, GATE syllabus not precise. GATE syllabus is not, you can say, very precise and all. So they can ask questions which are really out of box. Okay, so there is no guarantee that you will be able to solve questions of this topic. Sometimes questions are really very, very tough, and nobody can solve that in the particular amount of time or real time in GATE exam. Okay, because we have 3 hours and 65 questions, so around 2 to 3 minutes you have. So nobody can solve such kind of questions in 2 to 3 minutes. So my kind suggestion will be, you just leave those questions. Okay, leave those questions. Okay, we should leave those questions which are really very tough and all. So we will try to cover all the basics, and still covering basics will need lot of time. Okay, this is really a huge topic, and you will study that in your MTech. Okay, if you are interested in graph theory and all, you will study the details in your MTech. GATE has really basic syllabus only. Okay, and I will cover all those things, but there is no guarantee that you will be able to solve graph theory question in GATE exam, because sometimes questions are really very, very tough. Okay. Anyhow, the things which I will explain, that will be more than sufficient for all of you. Okay. Now let me jump to the next slide. So now we are going to start our first topic, that is the logic. Okay. This is the syllabus of logic. So total 7 topics we have to study in the logic. First is propositions, then we will study logical operators. This is and, or, not, NAND, NOR, XOR, implication, double implication. No need to write down all these things. When we will dig deep into the topics, we will definitely get the idea what are the names of the operators and all. Okay. Next will be rules of inference, then arguments, then quantifiers. Quantifier for all and there is, these are very, very important. Okay. Then is your predicate properties, again very, very important topic. Translations, again very, very important topic. Okay. So these are the 3 topics which are really very, very important for GATE, and almost every time questions have been asked from these 3 topics. Okay, and frankly speaking, these are a bit you can say difficult type of questions. Okay, the first 4 topics are really easy. You will be able to follow them very, very easily. Okay, but the problem is that questions have been asked very less, or few questions have been asked from these 4 topics. Okay, these 3 are really core topics and very, very important regarding GATE exam. Okay, yes, and the main thing is that 70% of the logic will be covered in these 4 topics. 30% logic will be left for this. Okay, and from 30%, more than 70% questions have been asked. So it's opposite way. From the 70% of the logic, only 30% questions have been asked in GATE exam. Okay, so small portion, but many questions have been asked from these 3 topics. Okay, please take snapshot or something. I will jump to the next slide. Okay, if anybody is having any doubt, please let me know. You can speak up with me. Okay, my mobile phone is not with me. Its battery is less, so I may not be able to see your chat. Okay, if you have any doubt, or if anybody sees any other student chat, please let me know, so that I can see the chat and answer your doubt. But please try to interact with me with voice. That will be better option, and it will save our time also. Okay. Now please take snapshot. I am jumping to next slide. Okay, so the very first topic in your logic is propositions. So let me tell you something about proposition. What is a proposition? Proposition is any declarative statement. Okay? Declarative statement means you are declaring something or you are telling something. Okay, any declarative statement which is either true or false but not both. Okay, any declarative statement which is either true or false but it cannot be both at the same time. This is known as proposition. So let me show you some examples. So moon is made of cheese. So I am declaring something. Now you are getting some information from me that moon is made of cheese. Obviously this statement is false. So forget about the statement is true or false. You should be able to assign one truth value. That means either true or false. Okay, but not both. You cannot give both. So this statement is clearly false, no problem, but still it is a proposition. Okay, next. Jupiter is made of gas. This statement is true, you already know, but no problem. Forget about the truth value. These are known as truth value. Truth value means the value which is assigned to your proposition. Okay, so again it is a proposition, no problem. Amit is tall. Yes, this statement can be either true or false, no problem. So it is also a proposition. But if we say he is tall, then who is he? Okay, so third person. So first person is Amit. Okay, I think from English you know this is a third person. Now, so third person is never a proposition because we do not know who is he here. Okay, these are some rules which you should remember. Yes, please take snapshot of something. I will jump to the next slide. If anybody is having any doubt, please let me know. Yes, I am jumping to the next slide now. Next is get out. So there is no information which you are getting from here. Okay, any command, I am giving you command now. So any and no command is a proposition. Okay, so it is not a proposition. What a car, an exclamation mark. It is never a proposition because there is no information which I am getting. Declarative statement. Now you should declare something. I am not declared anything here. Okay. Yes. So this is not a proposition. Okay. Now let me jump to the next slide. Yes. So who are you? This is again a question. Okay. This is again a question. So it is not a proposition. Okay, because I have to declare something. I'm not declaring here anything. Next is sum of 2 and 3 is 5. Again, I am declaring, I am telling you sum of 2 and 3 is 5. No doubt this statement is true and obviously it is a proposition. Next, sum of 2 and 3 is 6. No doubt statement is false, but it is a proposition because I am telling you something. You are getting some fact from here. Sum of x and y is 100. So now this statement can be either true or false. I do not know. Okay, because it depends on value of x and y. If x is 50, y is 50, it is true. If x is 20, y is 40, it is false, and so on. So I cannot assign any truth value to this statement because it depends on the value of x and y. So this is not a proposition. Okay. Yes. Please take snapshot or something. I will jump to the next slide now. Yes, please let me know once you are done. Please let me know.
Done, sir.
Okay. I'm jumping to next slide now. 4 is a prime number. Obviously, I'm giving you some information or some fact. Obviously, this is false, but it is a proposition. I have time and I will go to town. Again, I have time. I am declaring that I have time and I am declaring that I will go to town. No doubt it is a proposition. And let me tell you something. This is also a proposition. I have time. I will go to town. This is also a proposition. Okay. So I have applied and between them. So this becomes a compound proposition. It is a compound proposition. So this and is known as connective because it is connecting two propositions. Next is tomorrow it will rain. Yes, obviously tomorrow when tomorrow will come, I will get to know whether it rains or not. If it rains, I will say true. If it does not rain, I will say false. So obviously I can assign some truth value to it. So this is a proposition. Next is tomorrow it may rain. May is not a logical sentence. Okay, logic means true or false. So you can think of logic as black and white. Okay, either true or false. There is no gray kind of thing. Okay, either this side or this side. There is nothing in between. So there is no gray kind of thing. Okay, logic means black or white, no gray. So this is grayish kind of thing. Nah, it may rain. Okay, so I cannot say that this is true or false. So this is not a proposition. Everything is plant or animal. So no doubt this statement is false, because there are chair, table, monitor, keyboard, and so on. There are lots of things. No doubt this statement is false, but I am declaring something. Huh? So it is proposition. My name is Amit. I am declaring that my name is Amit. No problem. This is a proposition. Okay. Yes. Please take snapshot or something. I will jump to the next slide now.
Done, sir.
Okay. Yes, this board is white. Yes, I am declaring that this board is white. Proposition. This is a book. I am declaring that this is a book. No problem. This is also a proposition. Okay. Please take snapshot or something.
Over, sir.
Okay. Yes. Next is logical operators or connectives. Okay. So before starting these logical operators connective, let us study about logical or propositional variable. Okay. So in C language you have studied integer variable, float variable, and also integer variable, like we define integer x. So what it can hold? It can hold some integer value. Okay. If we define float x, float y, so it can hold some floating point value, say 5.2 and all. It can store say 3, 6 and so on. So something like integer it can store minus n to plus n. Okay, so it can store some integer quantity, it can store some floating point value and so on. So normally variable is used to hold some value. Okay, so same scenario here, propositional variable. So propositional variable will store what? Proposition. So propositional variable will store proposition. Like integer variable store integer value. So propositional variable will store proposition. Okay, so P is storing value, I have time. Q is storing value, I will go to market. So P and Q will be I have time and I will go to market. So this and is what? Connective. I have told you in the previous slide also, but still I am telling you so that everything get more clear to you. Okay. Please take snapshot of something. I will jump to the next slide now.
So?
Yes.
It is even called, as you said, compound proposition.
Yeah. This is a compound proposition. This entire thing is a compound proposition.
Done, sir. It is
Okay. Yes, so now we will study operators. Okay, I have told you the logical operators or connectives. So one and the same thing. You can call them as operators also. You can call them as connectives also. Why connective? Because they are connecting two propositions. Operators and or not, you already know. That's we are calling them as operator. Okay. So operators broadly are of two types. One is known as primary operator, and second is known as secondary operator. Primary are these three: and, or, not. And, or, not. These are known as primary, or you can call them as fundamental operators also. Fundamental operators also. Okay, so why and these are known as secondary operators. Secondary, this is NAND, this is NOR, XOR, this is implication, and this is double implication. Double implication. Yes, so totally we have 3 and 5, 8. Totally 8 operators we will study. So why they are known as fundamental or primary operator? Because with the help of these operators, I can design these. No problem in that. That's why they are known as secondary. They are known as secondary because primary can make them. Okay, with the help of and or a not, I can construct all these operators also. Anyhow, you have studied them in digital also, so I will just repeat it again. Okay, no problem. So these are primary or fundamental, and these are secondary operators. Okay, please note down. I will jump to the next slide.
Copied, sir.
Okay. Yes. So now we will study some properties of basic or fundamental operators. Okay. So and or and not are basic or fundamental operators. We will study their properties. Okay. So before jumping to property, let me tell you a very basic thing. In Boolean algebra, set theory and logic. Boolean algebra you have studied in your digital logic. Okay. Set theory we will study, no problem. And logic we are studying now. So all these three are interrelated with each other. Okay, how they are related? So in logic we say and like this. Okay, and in set theory this and is just like your intersection. I hope you have studied intersection. That means you take the common part between the two sets. That is intersection. And in Boolean algebra we have studied dot. Okay, these are one and the same. So my suggestion will be you follow Boolean algebra style, because you have already studied that in digital. Or if by the way if you have not studied, no problem, you will study it later. So the only thing is, if you go by Boolean algebra kind of thing, then everything will become very easy to you. You need not remember three things. You will remember only one thing, that is Boolean algebra. From Boolean algebra you can solve question of set theory, and from logic also. Okay, so it's your choice, whatever you want you can follow, but my request will be you should follow Boolean algebra kind of things. So as soon as you find the question of logic or set theory, immediately you convert them into Boolean algebra, and then you try to apply properties and all and try to solve it. Anyhow, I will show you all these things. Okay, so better is follow Boolean algebra kind of thing, because you will study one time here and then everything will be crystal clear in digital also and everywhere, no problem. Okay, so in logic we study or x or y like this. So in set theory it is x union y, and in Boolean algebra it is x plus y. Okay, so many of you have misunderstanding that dot means multiplication, plus means addition. No, it is not like that. These are the just symbols used in Boolean algebra. Okay, plus does not mean addition. Okay, please try to follow it. So x plus y, x union y, x or y, same scenario. In logic, not is represented like this, not of x. Okay, in Boolean algebra it will be represented like x bar, and in set theory it will be represented like x complement. Okay, so here in Boolean algebra this x and y are Boolean variable. In set theory x and y are sets, and in logic x and y are logic variables. No problem. Okay. Yes, so all these will be same. So we will focus on Boolean algebra, because once you study Boolean algebra properly, your digital logic part will be over. Please take snapshot. I will jump to the next slide.
Answer.
So now we will study truth table. I think you already know, but let me tell you something. So in logic, truth table will be formed like this. Logic variable, na a and b can have value true or false. So I will say like this: false, 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 true, true, false, true, true. A and B, A and B, A and B will be true when both inputs are true. Okay, otherwise it will be false like this. Okay, or I think you already know all these things. No? It's just simple. You can say revision kind of thing. Or means when at least one of them is true, output will be true. Not means you just reverse them. False will become true and true will become false. That's it. So this is the truth table according to logic style. Yes, done.
Yes, sir.
Okay. Next is truth table according to Boolean algebra. So in Boolean algebra, Boolean variable can take only two values, that is 0 and 1. So we will follow like this: 0 0, 0 1, 1 0, 1 1. Or output of OR is 1 when at least one of them is 1. No? So like this. And will be when both are 1. So this. Not when we will make 1 to 0, 0 to 1, 1 1, 0 0. Okay. Please take snapshot or something. I will jump to the next slide now.
Perfect, sir.
Next is truth table for the set theory. Okay, so for set theory, we will say, see this, in Boolean algebra we have 0. So in your logic we have false, and in case of set theory it will be represented by empty set phi. Okay, and in Boolean algebra we have 1. In logic we have true, and in your set theory that will be represented by universal set U. Okay, it's logical also. Now phi means what? Nothing. Okay, and universal set U means what? Everything is present. So true will be represented by universal set. So finally, how I will say, both are empty. One is empty, another is U. This is U, this is phi, and both are U. See, actually it's U like this only, but you will get confused with union. You will get confused with union. So that's why I am writing U like this. Okay, yes. So finally A union B. So I think you have got it now. So this will be phi, this will be universal set, universal set, universal set. Common part, intersection, phi, 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 and universal set. Complement, I think you have got it, universal set, phi, and phi. Okay, please take snapshot of something. I will jump to the next slide now.
Perfect, sir.
Yes, so I'm jumping now. So now we will start properties of your Boolean algebra. Okay, properties of these and, or, and not. Okay, and, or, and not. These are the basic operators, and now we are going to study their properties. Okay, so there are total 10 properties which we will study, and as it is, questions have been asked in GATE exam regarding these. 4, 5, 6, 7, 8, 9, and 10. Total 10 properties we will study. Okay. So commutative, associative, distributive, identity, complement, idempotent, absorption, law of double complement, De Morgan's domination. Total 10 we have to study. Please take snapshot. I will jump to the next slide now.
Done, sir.
Okay, so the first is commutative law. Okay, what is commutative law? So I will start from the Boolean algebra, because once we will study Boolean algebra, everything will be very, very easy. Boolean algebra will be like this: A dot B is equal to B dot A, and A plus B is equal to B plus A. Now please try to focus here. I am studying only these three things. Okay, and in case of logic is dot in Boolean algebra, or in case of logic is plus in Boolean algebra, and this will be like bar. Okay, and set theory, and will be represented like intersection, or will be represented like union, and not will be represented like complement, like this. So I'm just using all these things now. Commutative law in Boolean algebra will be like this. So how you will represent it in set theory? In set theory it will be A union B is equal to B union A, and A intersection B is equal to B intersection A. In logic, A or B is equal to B or A and B is equal to B and A. This is commutative. Okay. Yes. So please take snapshot. I will jump to the next slide now.
Done, sir.
Okay. So next is associative law. Okay, what exactly is associative law? See this. I will say like in Boolean algebra. First of all, in Boolean algebra, I will say A plus B plus C, that will be equal to A plus B plus C, like this. Okay, and A dot B dot C, that will be equal to A dot B dot C. That is Boolean algebra. Okay, and again I am repeating, only basic or fundamental operators we are studying. Okay, all these laws I am going to explain you from basic or fundamental. When we will study derived operators, then again we will study these things. Okay, no doubt that much detail we will not study, but I will give you at least some hints regarding all these properties. Okay, so now we will study only basic. That's it. Okay, now in case of set theory, I think it's just wastage of time. Okay, I think you already know all these things. You can do it yourself. Okay, and intersection A intersection B intersection C, that will be A intersection B intersection C. What about logic A or B or C? That is equal to A or B or C, and A and B and C, that is equal to A and B and C. Okay, so why we are calling them as associative law? Okay, so let me show you something. A plus B plus C. So now this B, it's the choice of B that it can associate with this plus also and this plus also. If this B associated with this plus, then we will get this. Now if this B is associated with this plus, we will get this. That's why I'm calling it as associative law. Okay, now please take snapshot. I will jump to the next slide.
Copied, sir.
Okay. Next is distributive law. Distributive law. So now I think I should focus on Boolean algebra only. Rest of these two you can do yourself also. Boolean algebra. So A dot B plus C, that will be A dot B plus A dot C, and A plus B dot C, that is equal to A plus B dot, sorry, A plus B dot A plus C, like this. So here I will say dot is distributed over plus. See here, dot is distributed over plus. A dot B plus A dot C. So dot is distributive over plus. Here I will say plus is distributive over dot. A plus B dot A plus C, like this. Okay, so these are the this is distributive law. If you want me to copy here, I can say like this: A intersection B union C, that will be A intersection B union A intersection C, and A union B intersection C, A union B intersection A union C, like this. Okay, same thing I think you can copy paste in the logic also. So please take it as your homework. You try to do it yourself. These are really very simple things. I should not waste time here for all these things. We have to study very big topics and very difficult topics also. So please try to follow it. Okay, I'm jumping to next slide now. Please take snapshot.
Copied, sir.
So next is identity law. Identity law in case of Boolean algebra I will show you. So it will be A dot 1, that will be A, and A plus 0, that will be A. This is identity law. In set theory, how you will say? Any set A intersection with universal set, you will get A, and any set A union with phi, you will get A. In logic, A, any logic variable A or 1, sorry, A and true, that will be A. Okay, and A or false, that will be A. Like this we will do. And why I'm calling it as identity law in group theory, I will explain. Okay, so here 1 is acting like identity, because with 1 I can get any Boolean algebra, Boolean variable, and I will get the same variable as it is. Okay, so 1 is identity for dot, and 0 is identity for plus. Okay, because you can add any Boolean variable with plus, with 0, you will get A. Okay, and so on, like this you can imagine. Yes, please take snapshot. I will jump to the next slide. And I'm not going into the proof and all these things. It's really not required, and you can prove them very easily from truth table and all those kind of things. Okay, if you want me to prove something, then let me show you something. Commutative law you can easily prove, like in Boolean algebra. So A, B, A dot B and B dot A, you can write it. No? 0 0 0 1 1 0 1 1 A dot B 0 0 0 1 B dot A will be same only 0 0 0 1. So finally I will say A dot B is same as B dot A. And not, that's why these are really very simple things. If everybody wants me to give proof and all, then I will obviously give it. Otherwise I can skip it. Okay, because you can make truth table and you can get all these things really very easily. This is the truth table. Same associative law you can prove yourself, no problem. Distributive law again you can prove yourself. Okay, so let me show you small hint if everybody wants. Then I will say like this: A, B, and C. Okay, 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. Okay, and then I will say it's really very big now. You will first find B plus C, then you will find A dot B plus C. Okay, then you will find A dot B, A dot C, and then you will apply plus between them, and then finally you will get the answer that A dot B plus C will be same as A dot B plus A dot C. Okay, you will find A dot B here, you will find A dot C here, then you will find A dot B plus A dot C. So finally whatever values you will get here, same values you will get here also. So I will say A dot B plus C same as A dot B plus A dot C. Like this we will explain. Like this we can prove. Okay, I am leaving it as homework for you. You can do it yourself. B plus C, what a big deal. You can easily find B plus C, and then you will A dot B plus C you have to find. So whatever you will get here, you will do AND with A. Okay, and same here. A dot B you will find, A dot C you will find, and then A dot B plus A dot C you will find, and so on. Okay, please do it yourself. It's really hectic kind of thing, and it will really waste our time, and it's not required for gate and all those things. So I'm not I'm not digging deeper into all this kind of things. It will waste our time. Okay. So I hope I have made the point clear to everyone. Yes. Okay. So yeah. So I have done identity law. Next is complement law. Okay. So for identity law again, you can do like this. Okay. A1. So A will be can take value 0 or 1. 1 will take value what? 1 only. Okay. So you will find A dot 1. So 0 dot 1 is 0. 1 dot 1 is 1. So what is A and A dot 1? Same. No? That's why I'm saying A dot 1 is equal to A. Similarly, you can prove A plus 0 is equal to A and all those things. Let me jump to the next slide. Complement law. Complement law says A plus A bar is equal to 1. A dot A bar is equal to 0. Now you can convert it into logic or set theory, like A union A complement, that will be universal set U. A intersection A complement, that will be phi. I think you already know common part between A and A complement will be what? Nothing, that will be phi. In logic, what you will say, A or not A. Okay, that will be true. And A and not A, that will be false. Okay, so 1 is true, 0 is false. Okay, universal set phi, all these things are same. I think I have told you in the slide. Now see this, I have told you where I have given, yeah, 0 false, phi same, 1 true, universal set same. I have told you. Okay, please take snapshot or something. Yeah,
phi and set theory.
Yeah.
A complement is universal how, sir? Or
No, I'm just saying A intersection
slide,
A.
sir, phi and phi.
First A union
is universal.
A union. This is union. A union A complement, that will be universal
Yes,
set U. Why this is true? You want to say?
Yes, sir.
Okay. So see, you just try to imagine set theory. So this is universal set U. Okay, and I have a set A like this. So what is A complement? A complement will be this entire part. So now you just union A with A complement, you will get the universal set U. Okay.
Answer the first slide. One thing, sir. union phi. I think
This one. Which
no
slide?
sir, previous one.
Yeah, this one. You want to ask
No
which?
sir, one more.
Yeah, here.
Sir, phi.
Your voice is breaking. A intersection A complement is equal to phi. Okay, so see this. What
Phi
is
is equal
A?
to phi, sir. Yes sir.
Yeah. Why this is what I'm saying. This is
A
A
is
set.
phi, sir. A is phi, sir.
Okay, when A is
Yes sir.
phi. Okay, then what you
Yes sir.
want to say?
Sir, if A and B both are phi,
And you want to take their intersection.
then union, sir.
Okay, so answer will be phi. Yes. But here I am taking A and A complement. I am not taking any two sets. I am
Yes
taking
sir.
A complement.
Yes sir. Okay.
Okay. Yes. So let me jump
Yes.
to the next slide. So this is all about complement law. So you just have to remember for Boolean algebra. Okay. A plus A bar is 1. A dot A bar is 0. That's it. Okay. Let me
So
jump to the
what is
next
the
slide. Your voice is
complement
breaking.
of phi, sir?
Complement of phi is
The
u.
complement of phi.
U.
Universal, sir.
U
Elaborate
complement is
just.
phi. Phi means nothing,
Okay.
na. So if you complement it, you will get the
Yes
universal
sir.
set itself. Okay, and if you take complement of universal set, you will get the phi. That means nothing will be there.
Yes sir.
Okay. Yes. So
Yes.
let me jump. Okay. Anyway, we will study all these things in set theory. When we will jump to set theory, we will study all these things. Okay. Yes. So next
Okay, sir.
is idempotent law. What is idempotent law? Idempotent law is A. In case of Boolean algebra, A plus A is A. A dot A is A. So in set theory, A union A is A intersection A is A. In logic, A or A is A and A is A. That is idempotent law. And you can easily prove it. Na A can take value 0 or 1, and again you write A can take 0 or 1. So A plus A will be what? 0 plus 0 is 0, 1 plus 1 is 1. A dot A will be what? 0, 1. So obviously A plus A dot A and A all are same. That's why I'm said A plus A is equal to A dot A is equal to A. This is Boolean algebra, so you can shift to logic and set theory also. So again and again you can see I am concentrating on Boolean algebra only, because from Boolean algebra I can shift all these things. Okay, let me jump to the next slide now. Okay. Next is law of double complement. This is again very easy. Double complement law means A bar bar that will be equal to A. In set theory, you will say A complement complement that will be again A. In logic, you will say not of A is A. Okay. So you can say like this. Yes. So not of A is A. And it's really very easy to prove. Na? A bar bar. So you take complement of A and then again you take the complement, you will again get A. It's really very easy. Okay, let me jump to the next slide now. Next is De Morgan's law. De Morgan's law says A plus B plus C dot dot dot. You take a whole bar, it will become A bar dot B bar dot C bar dot 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 like this. Okay. Similarly, A dot B dot C dot dot dot. It will become A bar plus B bar plus C bar and so on. You can easily prove it from truth table and all those things. I'm not going into proof. I will just tell you one thing very easy. So for example, A plus B whole bar. So how you will remember this law? You will say change the sign and break the line. Okay. So rather we should say first break the line and then change the sign. Break this line and then change the sign. So sign will become dot. So finally a plus b bar, it will be changed to a bar dot b bar. Okay. Similarly, if you have a dot b bar, so what it will look like? It will look, change the sign, break the line. Okay. So break this line and change this sign. You will become plus. Dot will become plus. Like this, you can remember. Okay, this is Boolean algebra. In set theory, you will say like this: A union B union C dot 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 dot. You take whole complement. So it will become A complement intersection B complement intersection C complement dot dot dot. Similarly, A intersection B intersection C dot dot dot. You take the whole complement. You will get A complement union B complement union C complement dot dot. In case of logic, you will say A or B or C dot dot dot, and you will apply not here. Okay, so what it will become? Not A and not B and not C dot. A intersection B, A and B and C dot dot dot. Not, it will become not A or not B or not C dot dot dot, like this. Okay. Yes. Please take snapshot or something. I will jump to the next slide now.
Done, sir.
Okay. I'm jumping to next slide now. Next is domination law. What is domination law? Like something is dominated. For example, if I say a plus 1, it will be 1. A dot 0, it will be 0. Okay. So plus means or. No? So or, in or, if any input is 1, then obviously output will be 1. And in case of and, if any input is 0, output will be 0. So you can easily prove that also. Okay. And in case of logic, what we will say, A or true, that will be true. A and false, that will be false. In set theory, A union, 1 means what? Universal set. So you will get what? Universal set. Okay. And if I say A intersection phi, what you will get? Phi. So domination means 1 has dominated the A, and answer is 1. 0 has dominated the A, so answer is 0. Okay. And what was your identity law? Identity law was just opposite of it. Okay. Identity law was saying A dot 1 was A and A plus 0 was A. Okay. That was identity law. Identity means it will not change. A will remain A. A will remain A only. Okay. Yes. Please take snapshot or something. This is domination law. Okay, 1 has dominated. So directly, indirectly, I will say like this: 1 plus A plus B plus C and so on. Anything can be there. It will be 1 only. Okay. This is really important. I will use it many times. So 1 plus something. 1 plus something. Whatever you write, it hardly matters to me. It will finally become 1 only. Yes. I'm jumping to next slide now. Next is absorption law. Okay.
Sir,
What is absorption?
A or true?
Yeah. In this slide, you have doubt?
Sir, A or how, sir? What we will take at the place of A?
A, you can 0 or 1 in Boolean algebra.
Elaborate with example, sir. Any small example?
Yes, 1 1. So A plus 1 will be what?
A or
T. This this one.
domination law.
हाँ. So
Logic.
ये वाला हाँ logic वाला. Okay.
A union. Yes, sir.
A or हाँ A or true. So A can take value either true or false. True will take obviously true. So now we want A or true. Okay. So what
Yes, sir.
true or true is true, false or true is true. So finally what we are getting? True. So A or true? True only. In case of false, so I will take false as false and false. So true, A can take either true or false. So A and false. A and false. So true and false is false. False and false is false. Finally what we are getting?
False.
False. Here false. Okay.
Yes. Okay,
Okay.
sir.
Yes. So let me jump to the next slide. Next is absorption law. In case of Boolean algebra, absorption law will look like this: A plus AB, that will be equal to A dot A plus B, that will be again A, and A plus A bar B, that will be A plus B. So three ways to define absorption law in Boolean algebra. So why I am calling it as absorption law? Because you can think A has absorbed this AB and you have got this A. Okay, and if you apply here distributive law, what you will get? A dot A plus A dot B. A dot A plus A dot B. Distributive law. So now A dot A is A. Domination law. Sorry, idempotent law. A dot A will be A plus AB. Same thing I have got it. So answer will be A. What about this scenario? A plus A bar B, that is equal to A plus B. So you just apply distributive law. A plus A bar B. So what it will become? A plus A bar dot A plus B. Are you getting it? A plus A bar dot A plus B. Plus is distributive over dot. That's why I have got it. So finally, what A plus A bar is 1. Complement law. 1 dot A plus B. So finally 1 dot something is identity law. A plus B. Yes, come again. A plus A bar is 1. Complement law. Yes. Anybody is having any doubt, please let me know. Let me write it. A plus A bar has become 1 because of complement law. I have told you complement law. And A plus B is same as it is. So now this entire thing, 1 dot this has become A plus B. Why? Because of identity law. If you have any doubt, then I will say 1 dot A plus B. Now you take it as X. So 1 dot X will be what? X only. I have told you. Identity law. So finally we have got A plus B. Yes, please let me know if anybody is having any doubt. So I think these three laws can be copy pasted in set theory also and can be copy pasted in logic also. This is homework for you. Please try to do it yourself. It's really very easy. A plus A dot B. Okay, so in logic what you will say, A or A and B. It will become A and so on. Please try to do it yourself. This is a really very easy task. Okay. If anybody is having any doubt, please let me know. A plus A bar B is A plus B only. So finally we have got A plus B.
Copy, sir.
Okay, now I will jump to the next slide now. Yes, so now we have studied all these 10 laws. 10 laws we have studied. So now we will try to solve these questions. Okay, so minimization questions will be asked in GATE exam also. Don't worry, I will jump to the GATE questions also. But let me focus on these simple questions first. P plus Q plus P bar. So first of all, this is which style? Boolean algebra style. So no need to change it, change and all those kinds of things. This is Boolean algebra. So I will directly solve it. So first, what I will do, I will take this Q plus P bar. I can change it as P bar plus Q. What is the name of the law? Name of the law is commutative law. Please try to write down all these things. Okay, if you write, you will get it. Otherwise, you will forget after 1 or 2 days. So better is try to write it with me. So the name of the law is commutative law. Commutative law. So now I will say P plus P bar is nothing but 1. 1 plus Q we will get. And what is the name of the law? P plus P bar is 1. Complement law. Complement law. 1 plus Q will be changed to 1. What is the name of the law? Domination. Domination law. Okay. So finally, I have to minimize it, and this has become what? This has become 1. Whenever you will get 1 as the answer, immediately you will say this is a tautology. Tautology means always true. So directly GATE exam will ask which of the following is tautology. So how you will prove it is a tautology? You just minimize it by applying the laws. Once you get the answer as 1, you will say it is a tautology. Okay, please take snapshot or something. I will jump to the next slide.
Done, sir.
Okay. Next is P or P bar or Q. So same. Okay. How this is looking like which kind of thing? Logic kind of thing. So step number 1 will be you just change it into Boolean algebra. So P or will be changed to plus. P bar it will become like this, and or will become plus, and then we will get Q. Same question which I have told you here. Same type of question is this. So step number 1 was change it into Boolean algebra. Okay. So Boolean algebra change. Okay, finally P plus P bar plus Q we are getting. So P plus P bar is what? 1. 1 plus Q. Name of the law? Complement law. Now 1 plus Q will become 1. What is the name of the law? Domination law. So finally we are getting 1 in, please now try to focus here. Finally we are getting 1 in Boolean algebra. But 1 will not be the option in GATE exam. Option will be what? 1 is changed to true. So finally after minimizing this will become true like this. So since it is we are getting true, so it will become a tautology. Okay. Yes, please take snapshot or something. I will jump to the next slide. So please, it's my humble request to all of you, do not leave answer in logic. You will not find in the option because question is of do not leave the question in answer in Boolean algebra. You will not find answer as 1 because question is of logic. So answer will be in the terms of true false kind of thing. So true will be the answer. Or indirectly they can ask forget about true. They can ask which of the following is tautology. Okay, like this. So if you have changed everything to Boolean algebra, finally from Boolean algebra you will change everything back to the same thing. Like logic, so you will come back to logic. Like set theory, you will come back to set theory. Okay, so it's just like this. If you have question, let me say here. So if you have question of set theory, you will first convert it into Boolean algebra, and when you will get answer, you will again convert it into set theory. If you have question of logic, you will convert it into Boolean algebra, and whatever answer you are getting, you again convert it into logic. Okay? Do not leave it in between. Okay. Please take snapshot. I will jump to the next slide.
Done, sir.
Okay. So next is P or I think we have done it. Huh? P or P bar or Q. So just leave it. Next is P and Q and P bar. Okay, let me do it. So how we will do it? First of all, I will say like this. This will be changed to P and okay, first of all, let me convert it into Boolean algebra because I will not do it like this. You will get confused. The thing which we have done, we should focus on that thing only. So P dot Q dot P bar like this. Okay, and will be converted to dot. Now I will change it to like this. P dot P bar dot Q like this. What is the name of the law? Commutative law. So finally, I have converted this to this commutative law. Commutative law. I am doing really very slowly so that you get more clarity of all these things. Okay, I can pick up speed also, but I am not picking speed right now because some of you may get confused. Okay, commutative law we have done. Now finally what I will say, I will change it like this. P dot P bar dot Q like this. Name of the law? Associative law. From here I have got it. What is the name of the law? Associative law. Now P dot P bar is what? 0 dot Q. Okay, so why we are what is the name of the law? P dot P bar is 0. Complement law. Complement law. Complement law, I think you remember, na? A plus A bar is 1 and A dot A bar is 0. So P dot P bar will become 0. Now 0 dot Q will become 0. What is the name of the law? Domination law. Okay. So the kind of fluency which I am having, if you are able to solve such kind of question in such fluency, you are through, no problem. Okay. If you are feeling any kind of doubt and all, please try to read all the laws again and again and try to practice more and more. You will get more clarity on all these things. Okay. So it's just like that. There are 10 laws. So these 10 laws should fit in your head very properly and very prominently, because many there are you can say at least there are 80 to 90% chances in GATE you will find questions on this topic, because it's not one topic, it's related to 3 topics: logic, Boolean algebra and set theory. So chances are there that definitely one of the question will be asked in GATE. Okay, so please try to focus here and try to properly understand all these 10 laws. Okay, let me jump to the next slide. Please take snapshot or something. Okay. Next is P or Q and P or Q bar. Okay. So step number 1 will be what? This is logic style. I will convert it into Boolean algebra. P plus Q dot P plus Q bar like this. Okay. So if you have a very good practice, you will immediately say like this. This P and P are matching now. You will immediately say, sir, P plus Q bar. This is the thing. That means you have just applied distributive law. So you just apply distributive law here. P plus Q dot Q bar. So it will become what? P plus Q dot P plus Q bar. You have got it the same thing. Are you getting it? P plus Q dot P plus Q bar. Same thing you are getting. So this is the way to check P and P are matching. Immediately you will say P plus Q dot Q bar. Like this. And you already know Q plus Q bar is what? 0. Name of, so first of all here, but I have applied distributive law. I have applied distributive law. Okay. Yes. And Q dot Q bar will become 0. What is the name of the law? Name of the law? Complement law. So finally I will get P plus 0. So what P plus 0 will become? P. Name of the law? Identity law. So finally, in case of Boolean algebra, I am getting answer P. So obviously, it will be just like this in logic only. Okay. So if we have some operator kind of thing, then I will change it. Otherwise, it will remain as it is only. So final answer will be P for this. Okay, and if you are not able to follow distributive law and all, then you have to do clerical work. Clerical work means what? You just try to open the bracket. If you try to open the bracket, what you will get? Let me show you here itself. Yes. So let me show you here itself. So what you will get finally? Let me make arrow here. Yes. Yes. So P dot P will be P. Okay, let me write it. P dot P plus P dot Q bar प्लस में q dot p प्लस में q dot q bar. So finally p dot p will become what? P dot p will become p. What is the name of the law? Idempotent law. Idempotent. प्लस में pq bar प्लस में qp प्लस में q dot q bar, it will become 0. Name of the law? Complement law. Now something plus 0, are you able to remember? A plus 0 is A only. So finally I will get p plus pq bar plus me qp. So name of the law? Name of the law is identity law. So finally I will say p plus pq bar plus me pq. Qp is changed to pq. Name of the law? Commutative law. So finally I will take p as common. 1 plus q bar plus me q. Okay, so I have just taken common, nothing more than that. So 1 plus something is 1 only. So p dot 1 I will get. Name of the law? Name of the law, domination law. 1 has dominated it. So finally p dot 1 will become p. Name of the law, p dot 1 will become p. Name of the law, identity law. You can think like this also. Q plus Q bar will become 1, complement law. That 1 plus 1 will become 1, idempotent law. Like this you can also say, no problem. Okay, but I am not digging deep into all these kinds of things. It will really waste our time. Okay, I just want to save our time. That's it. So you can do like this also. I have explained really very you can say by going into deep. Okay, I have dig deep and I have explained all the laws and then I have solved. Okay, otherwise I can directly say P is common, answer is P and so on. Okay, but I have explained each and everything. So if you want to do fluently, let me show you here. No problem. Let me show you here. I have shown you here by explaining laws and all. If you have done a good practice or you have a decent practice, how you will solve? Let me show you here. How you will solve? You will immediately say p dot p. Finally, you will say p. Okay, it will become p. Why? Because p dot p is p only, idempotent law. P plus pq bar plus qp. Immediately you will change it to pq. Qp, pq, one and the same thing. You already know. Q plus q bar is 0. So just remove it. So finally you will get this. So you will say p 1 plus so 1 plus something you will get. So you will immediately say p dot 1. So finally answer will be p. That's it. If you have good idea, if you have done good practice, immediately you will get this answer as p like this. Okay, so to make you fluent, I am giving you all these laws and hints and all those kinds of things. But if you have done good practice, you will immediately solve it like this. No problem. But my kind suggestion is try to focus here. P and P are matching. So P plus Q bar. That's it. Distributive law. Immediately you will get the answer as P. No need to worry. Okay. Please take snapshot or something. I will jump to the next slide.
Done, sir.
Hello, sir.
Yes. Yeah.
Sir, there is any analogy or something to remember, sir, distributive law and sir, absorption in shortcut or like that, sir?
See, you should if you try to write it, you will get the answer E plus Q dot R like this. So no need to remember. You just have to distribute plus over dot. So you will say P plus Q dot P plus R like this. I think you already know this thing from mathematics. P dot Q plus R. Yes, so what you say P dot Q plus P dot R. So dot has been distributed over plus now. So P dot Q plus P dot R. Like this you say. Now same thing you say here. P plus Q dot R. So P plus Q dot P plus R. So same thing now see. P and P are matching. So immediately you can convert it back to P plus QR. So same I have done. P and P are matching. So P plus Q bar like this.
Okay, sir.
And in case of absorption law, you just try to focus here. A plus AB. Immediately in your mind you will say, okay, A will become common, 1 plus B. Immediately A. No need to remember absorption law at all. You just simply say it is A. Similarly, A dot A plus B also, same thing, it will become A. Why? A dot A is A, and then A dot A is A plus AB. Same it will become. You just open the bracket, it will become same. It will become A. Okay, and third law was a bit tricky kind of thing. A plus A bar B. No problem. You just apply distributive law. Plus is distributive over dot. You just apply it and you will get the answer. What you will get? A plus B. So try to focus here. If A is here and A bar is here, you just remove A bar. You will get A plus B as the answer. Okay. So like this, I can say P plus P bar Q. Immediately you will say answer as P plus Q because of absorption law. Okay, C plus C bar D. Immediately you will say answer as C plus D, like this. Okay. So please take snapshot. I will jump to the next slide.
Okay, sir.
I'm jumping now. P and Q or P and Q bar. First of all, change it into Boolean algebra. PQ plus में PQ bar. Okay. So I think now it's very easy. P will be common, Q plus Q bar. Q plus Q bar is what? 1. Complement law. Finally, answer is P. Okay. So first step is I have converted into Boolean algebra. Second step is I have taken P as common. So Q plus Q bar is becoming 1. Complement law. And P dot 1 is becoming P. Name of the law? What is name of the law? P dot 1 is P. Identity law. Identity law. That's it. Yes. Let me jump to the next slide. I'm jumping now. PQR plus में P bar, Q bar R plus में PQR. So first of all, it is already in Boolean algebra. No need to do any kind of changing and all those things. So first of all, I will say like this. So now I think your mind will work. Now I think I should not do basics and all those things. PQR, PQR. Immediately you will say it will become PQ. Because A dot A is nothing but A. Idempotent law. Okay. Rather, if you want me to do step by step, I will say like this. First of all, I will change this. Take it as X and Y. X plus Y is Y plus X. Commutative law. So PQR plus में PQR plus में P bar Q bar R. Name of the law? Commutative. Then PQR plus में PQR. It will become PQR. Name of the law? Idempotent. Plus में P bar Q bar R. Okay. So now I think we cannot do anything extra. So if you want to take R as common, you will get PQ plus में P bar Q bar. Nothing can be done now. No problem. This is my answer. You can keep this as your answer also. No problem. Okay. Let me jump to the next slide
can
now.
you explain more? One more.
One more time. Okay. So PQR, P bar Q bar R plus में PQR. So you just swap them. Commutative law. You just swap them. You will get this PQR plus में P bar Q bar R. So PQR plus PQR. This is what? Take it as X and X. X plus X is what? X only. Idempotent law. Answer will be PQR. PQR plus में P bar Q bar R. So now nothing is. If you want to take R as common, you can take it. You will get PQ plus में P bar Q bar. That's it. Nothing can be done now. Okay, this is the minimized expression. Yes.
Sir,
I'm just.
we are doing here all third terms or commutative. Associated.
Yeah. No, this is common. Take it as X. Take it as Y. X plus Y is Y plus X. What is this? X plus Y is same as Y plus X. Commutative, na?
Yes, sir. Commutative.
Yes.
Yes, sir.
Okay.
Okay.
Please take snapshot. I will
Yes,
jump to the next.
thank you.
Okay. I'm jumping to next slide now. P and Q and PR and see this is what this is your logic. So first change it into Boolean algebra. P Q P R S bar like this. So I think this is really easy. You will change this Q dot P as P dot Q commutative law. P dot P dot Q dot R dot S bar. Name of the law is commutative. Then P dot P will become P Q R S bar. Name of the law idempotent. That's it. So P Q R S bar. This is my answer. So but this won't be the answer because we have converted answer as Boolean algebra. We want it in the logic style. So I will say P and Q and R and S bar. This is the answer. Okay. Please take snapshot or something. I will jump to the next slide now. I'm jumping now. P and Q or this. So I do not know how to do all these kinds of things. It will waste our time. I will convert it into Boolean algebra. PQ plus PQ RST. So finally, I think I should not waste time. I will say directly PQ plus में PQRST because we can flip the brackets. No problem in that kind of thing. Finally, this is what we got. So PQ will become common 1 plus RST. RST 1 plus something is 1 only. PQ plus 1. Name of the law? Name of the law? Domination law. So sorry, PQ plus 1 no, PQ dot 1. PQ dot 1. So finally, I will get answer as PQ. Finally, answer will be PQ. What is name of the law? Identity law. That's it. So final answer is PQ. So this is in Boolean algebra. I have to convert it into logic. Answer will be P and Q. That's it. Okay.
Okay, sir.
Yes. Please take snapshot. I will jump to the next slide. Okay, I'm jumping now. This expression. So again, I will first change it into Boolean algebra. T means true here. Okay, so they will say properly that T is not a variable. Anyway, in logic, we will not take T as a variable. We will take T as true only. So T will be changed to 1. 1 plus. Okay, or will become plus na. So PQ plus P bar and then Q plus P bar Q bar R bar plus में P bar Q S bar. Now you should immediately say, sir, 1 plus something we are getting na. So I should not write all these things. Immediately I will say this will become 1 because 1 plus something is nothing but 1 only. And 1 is in Boolean algebra, so in logic it will become T. So finally what we have got tautology. T means tautology, always true. So by seeing this also, without converting it to Boolean algebra, you will say true or something. Immediately answer will be true. That means tautology is the answer. Okay, answer is T. T means tautology, always true. Okay. So it directly indirectly it means whatever value you can give to P, Q, R, S, whatever are the variables, you can supply any value to them, either true or false. It hardly matters to me. Expression value will be true only. That is tautology. Okay,
Sir,
now yeah.
we can end with like 1 plus anything 1 or
Hmm.
that will be 1 only.
One only. Yes, I have told you. See the slide. One plus something.
So,
Yes.
yes, sir.
That
So, yes, sir. That's right.
we have got na identity law where I have told you.
Yes, sir.
Yeah, domination law. See this. One plus something is one only. Okay. You just add anything. It hardly
Yes.
matters to me. Answer will be one. Okay. Yeah.
Yes.
So yes, finally we have got answer as tautology. Yes. Let me jump to the next slide. I hope everybody has copied it. Yes. So I'm jumping now. So finally, see this. This is set theory
Yes.
kind of thing. So I do not know how to solve all this kinds of thing. It will really waste the time. So obviously, we can solve it by Venn diagram and all those kinds of things. If you do not know my shortcut, you have to apply Venn diagram and all. It will really waste time in. Kind suggestion is keep point of thing. Yes, please mute yourself. Please mute yourself. Yes. So Venn diagram. You have to do it by Venn diagram. Okay, if you do not know my shortcut and all, and it will be really horrible kind of thing in GATE exam if you go by Venn diagram. That's why such type of question have been asked in GATE repetitively, so that students waste their time. Okay, so you should not waste your time. You should get your answer here. Okay, so first of all, please tell me this thing: A minus B. So everything which is present in A but not in B, that is A minus B in set theory, na? So A minus B in set theory is equivalent to saying as A intersection B complement. You can check it out from your from Venn diagram also. Okay, for example, this is A and this is B. So what is A minus B? This part. Okay, let me write it. This is 1, this common part is 2, and this part is 3. So A minus B means what? 1 only. A minus B is 1 only. And what about A intersection B complement? A is what? 1 comma 2. B complement. B complement means what? B complement means 1, and here let us suppose 4. So what is the common part? 1 only. So A minus B is 1 and A intersection B complement is also 1. If anybody is having any doubt, please let me know that how I have done it. Please let me know if anybody is having any doubt. Is it okay to everyone?
Yes, sir. Clear, sir.
Okay, so finally A minus B and A intersection B complement are one and the same. So we will apply this trick because in Boolean algebra we do not have minus kind of thing. Okay, but we can change, we know how to change intersection and we know how to change complement in Boolean algebra. So directly indirectly what I will say, first I will say like this: A union B intersection C complement. Okay, and I want to say whether it is equal to A union B, and so this is you take it as X and this is you take it as Y. So X minus Y, so X intersection Y complement. So A union C whole complement. So now what we will do, we will first, now we have got it in set theory, pure normal set theory kind of thing. I will now change it into Boolean algebra. So what this will look like: A plus B C bar. And I want to prove that it is equal to A plus B dot A plus C whole bar. So A plus B C bar. So let me expand it. So A plus B dot A bar plus C bar. Which law? Which law is this? De Morgan's law. Change the sign, break the line. Okay, so finally now there is nothing A kind of thing or B kind of thing. So I have to open the bracket. There is no way out. Okay, if this was A, then I will immediately say A plus BC bar. But here we have got A bar. No problem. I will expand it. So A bar, I think I should not write it. It will become 0, but no problem. Let me do it step by step. A plus A bar plus में AC bar plus में BA bar plus में BC bar, like this. Okay, AA bar plus में AC bar plus में BA bar plus में BC bar. Now AA bar is nothing but 0. Okay, why 0? Why 0? Complement law. 0 plus something is, so I will get this thing only. So I will not waste time here. This we have got it. So finally, what we have got it, AC bar plus में A bar B plus में BC bar. Okay, and here what we are getting is A plus BC bar. Okay, so obviously these two are, so this is our answer. Now see this. We have got this thing. Now can anybody tell me these two are equal? No, they are not equal. So our claim that these two are equal is false. So directly, indirectly, what I will say, so see this clearly. If you try to see here, union and set difference. If you say, I will say A union B minus A union C. So I try to prove that union is distributive over set difference. False. This statement is false. So please try to focus here. Such kind of question have been asked in GATE many times. They will say union is distributive over set difference. Union is distributive over set difference. Union is distributive over set difference. This statement is clearly false. They will not say like this. They will say union is distributive over set difference. Directly they will say is this statement true or false. So if you want to prove it, is it true or false? We really don't know. Huh? Okay, so what I will do, I will change it like this. A union B minus C, that is equal to A union B minus A union C. Like this I will change. And after changing it, then I will try to solve and get the answer. And what I will say, union is distributive over set difference. This is false statement. Please try to follow it. If you have any doubt, please let me know. Have you got it now? Union is distributive over set difference. So A union B minus A union C. I have done it. So union is not distributive over set difference. Yes. Please take snapshot or something. I will jump to the next slide now.
Yes, sir.
Next is A intersection B minus C, that is equal to A intersection B minus A intersection C. Now clearly you have got it. So directly, indirectly, the question is intersection is distributive over set difference or not? Intersection is distributive over set difference. They will say like this. So is this statement true or false? So to prove this statement as true or false, what you will say, you will first get it this way. Now after getting this way, we really don't know how to solve it. First, we will convert it into logic style. How you will convert it into logic style? I will say like this: A intersection B intersection C complement. It will become A intersection B intersection A intersection C complement. I hope I have you have got it. Now B minus A is what? B intersection C complement. Okay, and you take it as X and you take it as Y. So X minus Y is what? X intersection Y complement. So this is your X as it is and Y complement. I hope I have made the point clear. Now what we will do? So now I will change it into Boolean algebra. So how I will change? I will say A dot B C bar. A dot B dot C bar. Is it equal to A dot B dot? So A intersection C complement. So A dot C bar like this. So A B C bar, A B, and I will apply De Morgan's law, A bar plus C bar. So A B C bar, A B A bar plus में A B C bar. A B A bar. I think we have got it. Now A bar B. So we will convert it and finally A bar cancelled out. It will become 0. If you have any doubt, then let me do it. So first of all, I will apply distributive, commutative law here. I will say like this: commutative law. Okay. Then after that, I will say A dot A bar will become what? 0, 0 dot B. Name of the law? Name of the law? Complement law. 0 dot B will become 0. Name of the law? Domination law. Very good. Domination law. So finally, step by step I have done it, but immediately if you have done good practice, you will immediately say, okay, A and A bar are coming now. You simply say it is 0. That's it. Okay, so finally what we will get, so 0 plus something plus A, B, C bar. A, B, C bar. So 0 plus something is something only. So A, B, C bar. What is name of the law? Name of the law is identity law. So finally we have got ABC bar. Here also ABC bar. Both are equal. So this statement is true. Like this you will prove. I am spending a lot of time in explaining you all these kinds of things. But it's really very, very easy. Immediately you will grasp it. A bar cancelled out. That's it. Immediately you can say. But I have explained it properly so that you get more clarity. Okay. Please take snapshot or something. I will jump to the next slide now. Done?
Yes, sir. Yes, sir.
Okay. A and B or A and B bar. Same kind of thing. So this is logic kind of thing. So I will say AB plus में AB bar. So A will become common, B plus B bar. So it will be A. I'm not writing laws again and again. It will waste our time. So firstly, I have converted into Boolean algebra. Okay. After that, I have taken A as common. No problem. And B plus B bar is what? B plus B bar is 1. Name of the law? Complement law. A dot 1 is A. Name of the law? Identity law. Yes, please take snapshot. I will jump to the next slide. Okay. A or B and A or B bar. So similarly, I will say like this: A plus B dot A plus B bar. Now I think you will be able to follow it. A and A same. A plus B bar. Finally, A is the answer. Please take snapshot. I will jump to the next slide. Jumping now. Yes, so again, this is set theory kind of thing. So I will change it into Boolean algebra. A plus A bar B plus AB bar. So A plus A bar B plus AB bar. A plus A bar B. If you try to remember absorption law, A plus B plus AB bar. So name of the law is absorption. So now I can take, now I should not waste time. I will simply say, okay, there are many ways of doing it. Let me show you the first way. B plus A B bar. If you solve it by absorption law, what you will get? A plus B plus A. Are you getting it? You just take it now. B bar A. So B plus B bar A. So it will become B plus A. So now A plus A is nothing but A only. We should not waste the time. Finally, I will get answer as A plus B. Now, if you do like this, A and AB bar, so A will become common, 1 plus B bar plus B. So 1 plus something is 1 only. So finally, I think I should not waste time. You will get A plus B as answer. One and the same thing. Many ways of doing same question. So I have shown you 2 ways. Okay, so you should now I think you should be enough mature and you should bypass the steps. Initially, I was not bypassing any step. I was telling you step by step, but now I think you are mature enough. So I'm bypassing the steps. So A, immediately I will say 1 plus B bar. So I will say A and so on. Okay, now please take snapshot. I will jump to the next slide. So if you have done pretty good practice, you will immediately say A plus AB bar. Okay, it will become A. And finally B is the answer. A plus B. That's it. Directly you will be able to say it. Okay, you should be enough mature to do all kind of things. Maturity will come by doing practice and practice. Let me jump to the next slide now. So this is clear-cut application of Boolean, your De Morgan's law. So first, what we will say, change the sign, break the line. So outermost bar, I will try to solve it. So I will delete it and I will make it as plus. Okay. Okay. So I should not do like this because you may feel trouble. Oh. Yes. Here I will do it because this was the question. So change the sign, break the line. So I will write here plus. So now we have two bars here. So obviously by law of double complement, a bar bar, that is equal to a, law of double complement. So I will delete those bars. So what I will get? Okay, let me write it. No problem. So finally, what I will get? A dot B dot A plus A dot B dot B. Okay, so now again change the sign, break the line. A bar plus B bar dot A plus A bar plus B bar dot B. A bar, I think it should be cancelled out. So A B bar plus A bar B. B bar will be cancelled out. So I have bypassed many steps here. I think you have got it. So finally, this is the answer. This is the answer. Since it was in Boolean algebra, so no problem. Answer I have got it in Boolean algebra only. Okay, please take snapshot. I will jump to the next slide. AB plus में AB bar plus में A bar B. So what we can do directly, I think you have done very good practice. So finally I will get A plus में A bar B. Finally I will get A plus B as the answer. I have bypassed many steps. I think you have got it now. A will be common, B plus B bar, that will be by complement or it will be cancelled. So A bar B as it is I have done taken here. So by absorption law I have got A plus B. If anybody is having any doubt, please let me know. Okay. So this much maturity I am expecting from all of you. Let me jump to the next slide now. So logic kind of thing. So I will say A plus C dot A bar plus B. Okay, A plus C dot A bar plus B. So now nothing is common and kind of thing. So I say if here A and here also A, I will immediately say A plus BC and all, but I'm not getting anything. So I will try to change it. A dot A bar is 0, so I will leave it. So finally what I will get, AB plus में A bar C plus में BC. Okay, so now this is a tricky question. This is a tricky question. In digital, you will study K-map, and once you study K-map, you will get the proof that why I am doing a crucial step here. Let me show you here. The step is, I will say like this: AB plus में A bar C, A plus A bar dot BC. Because A dot A bar is nothing but 1 only, na? So 1 dot BC is nothing but BC only. So with BC, I have done A plus A bar. So now when I expand it, what I will get, AB plus में A bar C plus में ABC plus में A bar and ABC. AB will be common, 1 plus C. It will be gone. Finally, AB is the answer. bar C plus में A bar BC. A bar C will be common. 1 plus B, it will be taken out. So finally we will get A bar C. So finally what we have got, AB plus में A bar C as our answer. AB plus में A bar C as our answer, and this was given to us. So after minimizing, I have got it. So when I will change it into logic, what I will get, A and B, A and B, or A bar and C. These and these are equivalent. Anyhow, you will prove all these things in K-map. Okay, no need to worry that why I have applied this A plus A bar and kind of thing. You may not be able to guess in GATE exam that how we are doing it. So in place of applying laws, which I have told you, you can solve it by K-map also. You will study that in digital logic, and once you study K-map, no need to apply these laws and kind of thing. Immediately by K-map you will solve and get the answer. So answer will be AB plus में A bar C. Please take snapshot or something. I will jump to the next slide now. Okay, I'm jumping now. A minus B. So same. So A intersection B complement whole complement. If you have not got it, let me write it again. How I have done it. First, try to change it. How you will change it? A intersection B complement like this. A minus like this. So A minus A intersection. Sorry. So A x minus y. So x intersection y complement. No? So A intersection B complement. So now I really don't know how to solve it. I will convert it into Boolean algebra. So A dot A B bar whole bar. So by De Morgan's law, I will say A bar plus B. Please apply brackets, otherwise you will get confused. By De Morgan's law, A bar plus B double bar. Law of double complement. It will become B. A dot A bar is nothing, becomes it will become 0. AB is my answer. So AB, when I will change it into set theory kind of thing, because this was set theory kind of thing, minus. So it will become A intersection B. So A minus B is nothing but A intersection B. Please try to follow it. Okay, I will use this kind of thing in DBMS when I will teach you Boolean relational algebra. So we will tell you that we have table 1 and table 2, and we want to find the common tuple between them. So how you will do it? We will do like this. So this is relation R1, relation R2. So I will say R1 minus R2, R1 minus R2 like this. We will get intersection of these two. This has been asked in GATE, by the way. This has been asked in GATE exam. Okay. So R1 minus R2, it will become nothing but R1 intersection R2. If you are able to follow, it's really good. If you are not able to follow, don't worry. I will teach this kind of thing in DBMS also. I have just linked these two things so that you get more clarity, and when we will study DBMS, you will get more information about all these things. Okay. Please take snapshot or something. I will jump to the next slide. Okay, now I'm jumping now. Next is B intersection A union B. Same. First of all, I will change it into Boolean algebra. So B dot A plus B. So what it will become? B dot A plus B dot B. So B dot B is nothing but B idempotent law. So B plus BA. So it will become B. 1 plus A, it will be cancelled. So it will become B. So finally, answer will be B. Please take snapshot. I will jump to the next slide now. I'm jumping now. So now we are going to study few GATE questions. So this is our first question. What it is saying, see again, this is really very hard. If you try to do it by Venn diagram and all, you will really get confused. So you just change it into Boolean algebra, you will get the answer. So what we will get, PQR प्लस में P bar QR प्लस में Q bar प्लस में R bar. I think you have got it, na? PQR plus में union means what? Plus P bar QR and so on. So immediately one thing will come to your mind. Answer here will be Q bar, because P plus P bar will be there. Q bar will be common. P plus P bar will be cancelled out, because by complement law it will become 1. So Q bar plus में Q bar plus में R bar. So Q bar plus में QR. So if you try to focus here, see this. A plus A bar B, that was A plus B, De Morgan's law. So you can think like this also. A bar plus में AB, it will become A bar plus में B. Why it will become A bar plus में B? Of course it is not absorption law, but I am saying you it will become A bar plus B. And how? You just apply distributive law. Plus is distributive over dot, na? So it will become what? A bar plus में A dot A bar plus में B. A bar plus में A is nothing but by complement law it will become 1. So 1 dot something is something only. So A bar plus में B is the answer. So same here, Q bar plus में QR. So it will become Q bar plus में R plus में R bar. Now immediately you will say R plus R bar is nothing but 1 by complement law. 1 plus Q bar. So 1 plus something is nothing but 1 only. 1 in Boolean algebra we are getting. So what in set theory what you will get? 1 was equivalent to universal set, na? So finally this will become equivalent to universal set U. This is the answer. Okay. And if they ask such kind of question in logic kind of thing, immediately you will say it is a tautology, because answer will be true. Okay. So if it was the question of logic, you will say it is a tautology. So answer is U. This is really very simple question. Okay. But if you try to do by Venn diagram, it will take a hell lot of time to solve this kind of things. So these are really very simple questions. Okay. Let me jump to the next slide. Please take snapshot or something. Okay. Next gate question. Again, oh, I think it's same to same, na? 2004. X bar Y bar plus में XY plus में X bar Y. So what you will do? So see this. Nothing is common here, but here we have common. But X bar. Y plus Y bar will be cancelled out. So X bar plus में XY. And I have told you just now it will become X bar plus में Y. If you have any doubt, please apply distributive law. Plus is distributive over dot. X bar plus में X dot X bar plus में Y. So finally we will get X bar plus में Y is the answer. Please take snapshot. I will jump to the next slide. Okay, I'm jumping now. Gate 2008 question. Similar kind of thing. So this is by the way in Boolean algebra only. So we will save our time here. So what should be done here? P plus में Q bar, PQ bar plus में PR plus में P bar, R bar plus में Q bar. So what thing can be done here? See, if you try to focus here, okay, if you try to focus here, something we are getting here and here. What is that? Q bar. Q bar. So immediately I will say Q bar plus में P dot P bar R bar. Are you getting it, na? See this. X plus में Y dot X plus में Z. It is nothing but X plus में YZ. I have told you many times. Okay, same thing, na? X and X. So I have got Q bar Q bar. So Q bar plus में P P bar R bar. P bar R bar is nothing but P bar is nothing but 0 only by complement law. So finally this thing will become 0. So 0 plus something is something only. So finally we will get Q bar. So from here and here I have got Q bar. So Q bar plus में PQ bar plus में PR. Sorry, dot, na? Dot. Q bar dot. Because these both have converted to Q bar. So Q bar dot PQ bar plus में PR. So finally what we will get? PQ bar. Okay, Q bar is nothing but Q bar only by idempotent law. PQ bar plus में PQ bar R. Okay. Yes. So now anything can be done. Yes, we can solve from here also. PQ bar will be common 1 plus R, and it will be gone. Answer will be PQ bar. So this will be changed to PQ bar only. Okay. So this is the kind of intelligence which you should develop. Otherwise, you will keep on solving the equations and you will waste hell lot of time in GATE exam doing this kind of thing. It will waste your time. So if you try to imagine, GATE exam is just like a gate. Okay. So gate. So you keep on tapping somewhere, you will not be able to open the gate. But once you tap the handle, immediately gate will open. So the handle step in this question was this. If you are able to imagine this thing, Q bar and this, finally you are getting Q bar, then this question is really very easy. In 2-3 steps it will be over. Otherwise you will waste hell lot of time in GATE exam. So I am telling you one thing. In GATE exam, each and every question can be solved in at most 3 to 4 steps. Rather I am saying 3 to 4, it should be done ideally in 2 to 3 steps only. If you are applying 5 steps, 10 steps, 20 steps, that means you are doing like this, tapping somewhere else. Handle is somewhere and you are tapping somewhere else. So your approach is not good. So no question will need 5 steps, 10 steps, 20 steps. No question will take in GATE exam. Those many steps are really not required. That means your approach is wrong. Ideally, you should be able to solve question in 2 to 3 or maximum 3 to 4 steps. Any question, any GATE question, I'm saying, any GATE question. Okay. So short questions have been asked in GATE. Lengthy questions have been not asked. No doubt there should be very big theory and all, but it's really just they want to waste your time. That's why they have made a big question. If you try to understand it and try to solve it, in maximum 2 to 3 steps, you will get the answer. Okay, now please take snapshot. I will jump to the next slide. So I think yeah, one more question is left. So I can give you as homework also, but it's really okay. Please try to do it yourself. It's really very easy. Please try to do it in your homework. In the next class, we will start from here itself. Okay. Yes, if anybody is having any doubt, already we are 3 minutes ahead. So if anybody is having any doubt, please let me know. Otherwise, I will stop the class here itself.
Clear, sir. Thank you, sir.
Okay then. So yes, okay then. Good night. Bye bye.